This is number 2 from 2.5 and 2.6 extra practice. It's one of these ladder problems, but it's a little bit different in that it says that the ladder starts vertically against the house, so it's straight up and down, and then it begins sliding out. So eventually it's going to look like the classic ladder problem. But instead of telling us what this distance is, it tells us how much time has passed. So it's going to, the setup is the same, but how we're going to solve it's a little bit different. So it tells us the base of this ladder moves that way at 1 foot per second. As that slides out, this side here does not change. We're going to call it X. As this slides down, this side changes. That side does change, sorry. This side is changing, so we're calling it X. This side is changing, so we need to call it a variable. This side does not change. It is always 10. So we can leave it as 10 instead of labeling it as a variable. Set up our Pythagorean theorem. Take the derivative with respect to time. And then plug in what we know. The problem is on this problem, they didn't tell us what X is. Usually they tell us what X is or they tell us what Y is. But we do know that 3 seconds have passed. So it started like this. And then the base moves this way at 1 foot per second for 3 seconds, which means X is going to be 3. dx dt, this side is getting bigger by 1 foot per second. We don't know what Y is. And we can't do something similar because Y, the speed of Y changes as it goes down. It speeds up as it's going further and further down. But we do know X is 3, and we do know this side is 10, so we can plug in 3 right here to get Y. 3 squared plus Y squared equals 10 squared. So Y is root 91. Subtract that over. And divide. So we have 6 divided by -2 root 91. We get negative because this side is decreasing in length, 0.314. We round to 3 decimal places. Question asked how fast something is moving. We usually report the positive value, 0.314 units are feet per second.